In this video, we're going to take a look at finding the equation of the standard form of a parabola. So, the lattice rectum of a parabola is a line segment that goes through the focus point and is parallel to the directrix line. We talked about focal length, which is the absolute value of p in the last tutorial. The focal diameter is the length of the lattice rectum and is the absolute value of 4 times p. So if this is our parabola, here's our focus point. Our lattice rectum is going to go through the focus point, be parallel to the directrix line, and its length is going to be the absolute value of 4 times p. So example 3, find the standard form of the parabola with a focus point of 2, 1. So here's our focus point. And our directrix line is y equals negative 4. So here's our directrix line. So first up, the vertex, if the distance from the vertex to the focus point equals the distance from the vertex to the directrix line, then the vertex is going to be the midpoint of the segment that connects the focus point with the directrix line. In other words, if we take this point on the directrix line and find the midpoint of that point with the focus point, we'll have our vertex. So finding the midpoint of these two, just average the x coordinates, average the y coordinates, we'll get a midpoint of about 2 and 1.5. So, or negative 1.5, I should say. So our vertex of our parabola is 2 and negative 1.5. And because the focus point is above the parabola, our parabola is going to open upward. Remember, the focus point is always inside the parabola. Another way to look at it is the directrix line will never ever intersect the parabola at all. So we don't want it opening to the right, we don't want it opening to the left, and we certainly don't want it opening downward. So only one way it could go is up. So our value of p, if we take a look at the distance from, let's say, the vertex to the focus, is 2.5. So if we multiply that by 4, we get 10. So the 4p that we saw out in front of our equations earlier in the last tutorial video, the absolute value of that is the lattice rectum length. So we have a value of 4p is 10. So if we put it all together, we have our x coordinate of our vertex is 2, so x minus 2 squared. 4 times p is 10, and then y minus negative 1.5 becomes y plus y.5, and that's what our parabola will ultimately look like. So find the vertex, calculate the value of p, take 4 times that value of p to get the coefficient for, in this case, the y at plus 1.5. So to convert parabolas that are in the ax squared plus bx plus c form to standard form, we're going to do the following. We're going to find the coordinates of the vertex. That gives us the value of h and k, which we can do either with or without technology. And then we can use the relationship that 4 times p is 1 over a. So it's going to be 4 times p is the reciprocal of this value of a that's in front of the x squared, the leading coefficient. So example 4a, we're going to find the vertex, focus, and directrix for the following graphs. We have y squared plus 4y plus 8x equals 4. So if we graph that, here's what it's going to look like. It's going to open to the left, and it would appear as if our vertex then is going to be at 1, negative 2. So we can use technology for that. We can also use some algebraic techniques as well. So 1, negative 2. So 4 times p is going to equal the absolute value of 8. It's going to be what's in front of the x. And then we're going to have p equals 2. So our focus point is at negative 1, or is at 1 minus 2, comma negative 2. So it's 2 spaces to the left. Our directrix line is going to be 2 spaces to the right. So our focus point is at negative 1, negative 2. And our directrix line is going to be x equals 1 plus 2, which is x equals 3. So again, we can use technology to find the coordinates of the vertex, which in this case are going to be at 1, negative 2. Whatever's in front of x in this case, we're going to set 4p equal to the absolute value of that, divide and we'll get p equals 2. So going to the left 2 spaces for our focus point and going to the right 2 spaces for our directrix line gives us a vertex of 1, -2, a focus point of -1, -2, and a directrix equation of x equals 3. All right, for part B, we have x squared now equal minus 2x plus 5y equals 1. So this time our parabola is going to open downward. So we graph this. We get this parabola. We can find the vertex using technology. Is that going to be at 1 and 2/5? So an x coordinate of 1 and a y coordinate of 2/5. So the coefficient of y, the other variable, is 5. So we do 4 times p equals the absolute value of 5. We'll get p is 5/4. So we're going to count 5/4 of a unit down below the vertex to get our focus point, and 5/4 of a unit above the vertex to get the directrix line. So our focus point is going to have the same x coordinate as our vertex, but then we're going to take that 2/5 and subtract 5/4 from it. So we're going to subtract the 5/4 from the y coordinate of that vertex, and when we do that, we get -17/20. So this blue point has coordinates 1, -17/20. To get our directrix line, we're going to add 5/4 to the y coordinate of our vertex. So 2/5 and 5/4 gives us 33/20. So our equation for our directrix line is going to be y equals 33/20. So just to recap, vertex, which we can find using technology, is at 1 and 2/5. Our focus point is at 1 and -17/20. And our equation for our directrix line is y equals 33/20. All right, that about does it for this video, and I will see you next time.